Welcome to the section about combining promises, which will show another great feature of promises related to process flows. In section 3, we have made good progress on asynchronous flows. We know how to redirect a flow, prepare values before passing them on, etc. In this section, we will talk further about how promises can help us easily handle asynchronous flows. We are going to start with a case where we have several asynchronous actions running in parallel. This will be pretty straightforward. In the next video, we will see a really great tool which allows us to run processes in parallel, but wait for all of them to be complete before moving forward. Finally, we will look at a series flow, but with a twist this time, since we will, on the fly, define how many asynchronous processes we will run in series. Let's start with parallel and independent tasks. This case will be very straightforward. We will create several promises to each represent an asynchronous task, and we will let them run. For each of the promises, separately, we will handle the result using a .then. Within the code, we will add logs so we can see the order of the processes. As an example, we will build a widget that displays the current number of people in space, as well as the current location of the International Space Station. Let's open index.html and have a look at the markup created for the widget. Once again, we have a controller which we will code, and within the panel body, there are two columns, one to display the list of people in space using the ng repeat here, and we can see that we're expecting iss.people to be an array, since we use the length attribute to display the number of people. And in the second column, we'll be displaying the current latitude and longitude of the International Space Station. Let's get started on the controller. We will need $HTTP, since the information we need can be obtained from the OpenNotify API. So let's dependency inject $HTTP. We create the $scope.iss empty object. We will add its properties as we receive the position and list of people. The information comes from two different API points though, so let's create var peoplePromise equals $HTTP.jsonp and then the URL to get the astros. We have to use JSONP because CORS is not implemented on that API. And then create position promise equals $HTTP.jsonp and the URL that provides the current position information. Let's handle the results of the two promises. Starting with peoplePromise.then and a function, and we will receive a HTTP response. We want to grab the data, and on the data we'll find an array called people, which is exactly what we need. Let's add a console log here so we will see later when this task completes. Moving on to the position promise, we are more or less doing the same, but this time it's data.issPosition, which we assign to $scope.iss.longitude to match the index.html markup. Add a console log within the .then callback, and let's also add one more console.debug outside of those promises. Now this part is synchronous, so it will always complete first. We're ready to switch to the browser with the dev console open. You can see that the data is loaded independently for the position and the people. As expected, the synchronous part is always going to be first, but if we reload the page several times, you can see that the position call sometimes completes first, sometimes after the people API. This is something we always have to keep in mind when working with asynchronous flows. There is no way of knowing which process will complete first. So in this video, we saw a simple example of two promises that run concurrently and independently. We also pointed that in an asynchronous flow, we can never assume to know the order in which tasks complete. This can sometimes lead to race conditions if the tasks are interdependent. In the next video, we will see how promises help us deal with that problem.